Hey class, this video is on Pythagorean theorem. So we're gonna go ahead and go over the definition, the formulas, some examples. I'm gonna try to go through this fast. So if I'm going too fast, make sure that you pause it, rewind it, rewatch it. Okay. So what is the Pythagorean theorem? I'm gonna have you guys fill in the blanks. It states if a triangle is a right triangle, that meaning it has a 90-degree angle, then we can use this formula. The Pythagorean theorem, which is a squared plus b squared is equal to c squared. The converse of that, now when you have an if and then statement, that means if a, then b. The converse of that means if b, then a. You're just switching the two things. So the converse of the Pythagorean theorem is if a squared plus b squared is equal to c squared. If that is true, then we can determine that a triangle is a right triangle. Okay, so a couple of different things. I'm hitting you guys with a lot of letters. Let's talk about what these things are. In a right triangle, the A and B, those are what we call are the legs. Just like how you have two legs, the triangle also has two legs. Here, the legs are next to the right angle, so this is the right angle over here. It could be B and A, but these things can be switched. That's not really too important. I could put A here and B here. They're interchangeable. A new vocabulary term is what represents C in a right triangle is called the hypotenuse. It is always the longest side of a right triangle, and it's always the opposite side of a right triangle. It's always opposite of the right angle. Okay. So let's go and look at why is this true. So I have this example here. Now when you think of, so we have a squared. When you think of squared, you can think of as an exponent. But you can also think of like the actual shape of what a square is. So we're going to look at the side lengths over here. This side over here, we're going to call that's going to be our A. Looking at that is a height of, or distance of 3. Notice how there's like 3 boxes. Off to the right, we'll make this our B. That'll be 4, because there are 4 boxes lined up against the edge of the triangle. And on the opposite side, our C is 5. So we're going to plug in those values for A, B, and C. So instead of a squared, we're going to have 3 squared plus 4 squared equal to 5 squared. Just like I said, you can think of the actual shape of a square. 3 squared is 3 times 3, which is 9. Now, the reason it's 9, and you can look at right over here on this square, there are 9, this bigger square is composed of 9 smaller squares. On the 4 square, we should already know that is 16. And if you count it out, there's 16 squares underneath. And off where the hypotenuse is, 5 squared is 25. Just simplifying the left side, 9 plus 16 is 25. Right, so it's taken from this visual shape that when you have the square over here, when you add them up, it always, 100% of the time, equals the square for the hypotenuse, right? And that's if it is a right triangle. Only works for right triangles, doesn't work for acute, doesn't work for obtuse, only for this. Okay, now we're going to use the converse. If a squared plus b squared is equal to c squared, then a triangle is a right triangle. So here, for example 1, we're trying to determine, is this a right angle? You can't assume that it's a right angle even though it looks like it. It has to have that little box. If it doesn't, we can see if it is a right triangle by testing it. So let's go ahead, and this looks like the one that's gonna look like a right triangle or right angle. So let's go and label some things. I'm gonna put that this is A, this is B, and this has got to be C. Our hypotenuse is the longest side. It's also the longest or the biggest number. So let's go ahead and plug that into here. So if this is true, if I get a true statement, then this is a right triangle. If not, then it's not a right triangle. Okay, 3 squared is 9, 5 squared is 25, 8 squared is 64. If I add up 9 and 25, that is 34. 34 equal to 64. Now, this is not true. It is not equal. So what can we determine from that is that this is not a right triangle. Pretty much it. So that's coming from this definition, right? This wasn't true, therefore this isn't true. It's not going to be a right triangle. Okay. We're going to do another example of this. I should not put that right angle there, so I just put a question mark in red. And I've already plugged it in here. So 6 is representing A, 8 representing B, and 10 representing C. So 6 squared is 36. 8 squared is 64. 10 squared is 100. If I add up the left side, 36 plus 64 is 100. We get 100 equal to 100. That's a true statement. But the thing is, what does this mean though? This means since it is true, this is a right triangle. Alright. Now, in using this formula, we're going to have to find missing values. So we have two examples there. Our first one is where we have a missing hypotenuse. So we have a variable here for x. I'll make this A, this B, and yeah, you can make this represented as C, but we have an x there. Doesn't really matter. So let's go ahead and plug in these values. We're going to have 2 squared plus 5 squared equal to, we'll write it as x squared. How I'm going to figure out what this value of x is I have to simplify and solve for x. So we've done this when we have solving squared equations. So 2 squared is 4, 5 squared is 25, x squared is just x squared. If I add up the left side, that'll be 29 equal to x squared. Now, I don't have x solved for, so what we have to do is we have to square root both sides. On the right side, we're just going to get x because squares and do square roots. And on the left side, you can do a factor tree of 29 because this is going to be irrational, but the thing is you're not going to have any pairs that you can pull out. So this just simplifies to radical 29. Now, something that's a little bit different than when we had squared equations is, notice how I'm not putting the plus or minus sign. The reason is because distances are always measured as positive. You wouldn't say that this is a negative distance. Like, I wouldn't say that this paper is a negative 11 inches. It's 11 inches. That's represented by a positive value. Okay, so we don't ever put plus or minus for when we're measuring distances. Okay. All right, now we have a missing leg, so I just drew a stick man with a missing leg. Hopefully that's a good visual. We're gonna have this as A, B, and this one will be C. So I'm gonna rewrite it as x squared plus 12 squared equal to 13 squared. Simplify it, we're gonna get x squared plus 12 squared is 144, 13 squared is 169. And from here, I have to solve for x squared. I'm gonna have to isolate that, so I'm gonna have to subtract 144 to both sides. We're gonna get x squared equal to, that's a 25. This is gonna be 25. All right, same exact thing, square root both sides. We're gonna get x equal to, and it's just gonna be positive 5. So here, this missing value is 5. So 5 squared plus 12 squared is equal to 13 squared. Now, something I'm missing from this notes is that we always want to label our units. So if it says centimeters, make sure you put centimeters, miles, put miles. That's something I'm neglecting to do. If you never see a unit though, if it doesn't show one, you're always going to put UN. It's just abbreviation for unit. So I'm going to put that this is radical 29 UN units. All right, guys, that's been pretty much it. Let me know if you guys got questions. Bye.